Are you tired of getting lost using geometry nodes? I will show you how I started figuring out geometry nodes in Blender. In this video I will walk you through the basic logic of geometry nodes and everything I wish I knew when I started. I will cover the creation of this simple stairs asset, going through the steps I followed and the logic behind it, just the way it made sense to me. I know it is tempting to jump into making complex assets right away. But even the more advanced setups I've worked on came from really simple ideas and basic procedural logic. All these scenes I'm showing here were made with the help of a single geometry nodes asset that follows the same logic I'm going to show you step by step. With your Blender open, select your default cube, go to your timeline and change the panel to the geometry nodes editor. Click on New. You can scroll your mouse like you do it on the viewport to zoom. The same commands of navigation applies here too. Now go to your modifiers on the Properties tab to see the geometry nodes applied to your object. As you can see, we have two nodes connected, Group Input and Group Output. To disconnect it, press Ctrl and click and drag with your right mouse button, and the geometry disappears. To show it again, just connect both sockets. The logic here is really simple. Geometry nodes is displaying only the geometry that is being passed from group input to group output, and everything you add between them will affect your geometry. Make sure your mouse is over the geometry nodes panel and press Shift A. You have multiple categories of nodes to choose from. For now, let's select Mesh Primitive Grid. After you place it somewhere, just delete it. The fastest way to add a node is to press Shift A and automatically start typing the name of the node you want. Note that when we add the grid node, nothing happens. It is because for the grid to show, it needs to be connected to the group output. The grid node is a simple but powerful primitive because you can create a lot of stuff with it. Try changing its X and Y size here. The vertices are the subdivision of the grid on each axis, but to be able to see it, you need to enable the wireframe overlay. So just like in modeling, we have access to the edges, faces and vertices of a mesh. The difference is that we can manipulate and change the parameters as we go. And there is a powerful node to help us to see these attributes, the viewer node. To enable it, you press Ctrl-Shift left mouse button on the desired node. Now we can add a index node to see the number of each vertex. But we also have to go to the Overlays tab and enable Attribute Text in order to see the indexes. We can also see all the attributes in a geometry using the Spreadsheet. Click and drag on the top corner to create a new area and select the Spreadsheet. The Spreadsheet is really great for debugging geometry nodes. It is used to inspect the geometry nodes attributes, like the position of the vertices you can see on the panel. Here I am subdividing the grid to see more attributes being created on the spreadsheet. For now, I just wanted you to know that this editor exists and it can be really helpful for you in the future. For now, close it and add a set position node. Place it right between the grid and the group output. With this node, we can change the position of our mesh. This is one of the most used nodes, but it's not the only one that can do that. We can also use a transform geometry. To disconnect the set position and keep the link, press Alt left mouse button, click and drag. Now place the transform geometry there, and as you can see, we can also change its position using this node. Now, you must understand the difference between these two nodes. Note that the set position node has 3 diamond sockets: selection, position and offset. This node lets us select specific vertices and change its attribute because it can work with fields accepting multiple values at the same time. On the other hand, the transform geometry lets you translate, rotate and scale, but it doesn't accept fields affecting your geometry as a whole. A field is a function, a set of instructions that can transform an arbitrary number of inputs into a single output. Field's result can then be calculated many times with different input data. They are used all over geometry nodes to allow calculations that have different results for every element, like mesh vertices, faces, and so on. Another thing that is really important to point out is that node sockets may have different shapes or color depending on the type of data they work with. Rounded sockets requires a single real value, while the diamond socket can either accept or output a field. And the diamond socket with a dot in the middle can be a field, but it is currently a single value. On the right, there are the types of data used in geometry nodes and their corresponding socket colors. I know that some concepts may look abstract, but you get it as you go. Now let's go back to a more practical example. Press Shift A again, go to Utilities, Math, and select the Compare node. Make some room for the node, and we are going to use it to select a specific vertex and move it. Change the data type to integer and change the operation to equal. Click and drag on the socket and release to add index. Connect the result to the selection and experiment, changing the offset values. Basically what we are doing here is selecting a vertex with the index 0. Using the viewer node we can see exactly that. Connect the index to the viewer, clicking and dragging with the shift and right mouse button pressed, you can reroute the node path. Select and press G to move it. If we change the number on the math node we can switch between the indexes. Okay, let's clean this up and start working on the stairs. We can promote the size of our grid to be able to change it outside the geometry nodes panel. This way it gets easier to change the values, but we do not want the grid to scale from its center. We need it to scale from a corner. We need to add a combine node to be able to change each axis individually. Connect size X to the X in the combine X, Y, and Z node. Note that the grid jumped to the side, and as we scale it, it doesn't seem right. For it to work, we can add a math node and set it to divide. Change the value to 2. It's like we changed its anchor point. And just do the same thing for the Y size. Now we have our plane scaling from the point we want. Here's the example of the plane being instanced on a diagonal line. For that, add a curved line node. Connect the curved line to the group output to see it. Let's change the endpoint position to keep it on the X and Y axis, making a diagonal line. If we take a closer look with the viewer node, we can see that we have 2 curve points, one at the start and one at the end. What we need to do is add a resample curve node to increase this number. Now our line has 10 points and we need to instance the grid on each one of them. We can add an instance on points nodes for that. Connect our resample curve to the points socket and the set position coming from our grid to the instance. Here we have our grids. We just need to space a little bit the points of the curve. If you click and drag, you can change both values at the same time. Now adjust the size and number of steps, and we are almost done. To give the steps some depth, add a extrude mesh node. There you go. But note that it leaves the bottom open. To fix that, add a join geometry node and join the extrude mesh with the instance on points node. Now we have the bottom, but if you take a closer look on the face orientation, you see the normal facing the wrong side. And it's really easy to fix it. Just place a flip faces node. Now our hole in the bottom is fixed. If you hover your mouse over the join geometry socket, you can see we have 32 instances coming out of it. 16 from flip faces and 16 from extrude mesh. To convert the instances to mesh, we need to add a realize instances node. Now if we take a look, we can see the vertices, edges and faces. We need to do this in order to add a final node, the merge by distance node. What this node does is look for any vertices within the specified range and merge them together. This way we have a geometry and we can add even other modifiers like the bevel modifier after the geometry nodes, and you will see it will work nicely. But look what happens as soon as you unplug the merge by distance node. The bottom is no longer connected to the rest of the geometry, so it does not get affected by the bevel modifier. Let's plug it back, adjust the bevel and rotate our stairs. I am using the shortcut R, selecting X and typing 90 degrees. Now you are just left to adjust parameters like extrude. The bevel is optional, of course. You can change the number of steps as well as the height or direction of the stairs. This is just a simple example for you to understand the basics of geometry nodes. And I know you can do this example even faster using just the array modifier and traditional Blender workflow. The difference is that geometry nodes lets you create an asset that you can use in other projects when you need it, and you don't have to build it all over again. And as soon as you want more control or specific features in your model, you will see that geometry nodes will be really helpful instead of using the traditional modifiers. Because geometry nodes lets you have almost full control over what you want to do. Now that we know the basics, let's build a more challenging node tree. Now let's select this part of our nodes and delete it. Keep just the grid in the beginning. Clear the rotation of the plane so we can keep it on the X and Y coordinates. Okay, so now we have a plane that we want to repeat it to form a full stairs. And we need to increase one step every time we repeat on the X coordinate. To do that, we will use the repeat zone. Press Shift A and type repeat, you will find it. Let's use it to see how it works. Connect your geometry to the input socket and the output to the group output. And even when we change the iterations, nothing seems to happen. That's because we have nothing affecting our geometry on each iteration. Now try placing a set position node inside the repeat zone. Add some value to it. And as you can see, on each iteration the set position gets added again. But if you hover your mouse over the output, you will see we have only one face. I am changing the offset to 1 meter to place the face exactly on the squares in the grid. Now on each iteration, the face will have a different position. But we also want to have a new face every time we change the position, because right now the geometry is being affected by the set position and coming back to be affected again, but it's always the same geometry. Now look what happens if we added join geometry node and connect the input to it. As you change the iteration, you see it seems to work, but it has a trick. As we hover the mouse, we can see we have 8 faces, but we only have 3 iterations, 4 if you count the 0. But on the viewport we see 4 faces, because the extra faces are stacked on the same position of the other ones. I am converting the geometry nodes to mesh just to show you all the hidden faces. Let's go back and see why this happens. If you take a closer look, we are inputting the geometry and duplicating every time we make a new iteration. But there is an easy fix to this. Break the connection to the geometry socket in the repeat zone, and also this connection inside. Connect the set position directly to the join geometry by passing the input on the repeat node. We are adding a new face every time and pushing everything to the side. Now we need the steps to go up. I am pressing Shift D to duplicate the set position and change the y-axis to 1. We have something similar to what we did with the curve line and the instance on points node, but with a different setup. And you will see that there are many ways to achieve the same result with geometry nodes. But now we need to fill all these squares to make a full stairs. Remove the second set position and let's add a new repeat zone. We will use the set position to move the faces up. Duplicate the join geometry and move to the second repeat zone. Connect the set position directly to the join geometry of the second repeat zone to preview it and see if it's working. Change back the viewer node to the first repeat zone and connect the output to the join geometry of the first. We now have a setup for a grid, but we need the stairs going up one step at a time. To do that, simply connect the iteration of the first repeat zone to the second. Now we have a loop or a repeat zone inside another repeat zone. And you can hover your mouse over the output to see if you have 6 faces, like we are seeing on the viewport. You can also use a viewer node and an index node to check it out. Remember on the viewer node to change from auto to face. Now we can see every face index. We are almost there, but there is still a problem. If you try to change the size of the steps, you will see we need to fix this. And it's easy to do. Duplicate the combine X, Y, and Z node. Take the X value from the math node to the X and then to the set position on the first repeat zone. As you can see, we have some faces overlapping. To fix this, we actually have to grab the value directly from the size X into the combine X, Y, and Z node, and then do the same thing for the y-axis, and you are good to go. And we are almost done. We just need to give some depth to the stairs. I will go faster because we already know these nodes. Add the extrude mesh node, look under the mesh, and you will see that it is extruding the individual faces. Uncheck the individual box, but nothing is happening. It's because we need to merge all the faces together before extruding it. Next steps to fix the hole like we did before, using a flip faces node, a join geometry, and merging everything again all together. Promote the main values so it can be easily accessed on the properties panel, like the extrude value and the iteration of the repeat zone. Organize a little bit the position of the nodes to look better. Rotate your object in the viewport so the stairs stands up. I also want to change this behavior of the geometry extruding from the side, changing its anchor point in geometry nodes. To do that, we need to compensate the extrude with the transform geometry. Now it appears to change from the center. And you are done. Here's the full setup of the stairs asset. Try playing with it to see what you can come up with. And don't forget you can use other modifiers after the geometry nodes, since your mesh is all quads, meaning it can be deformed without any problem. Try using the curve modifier to make a spiral, stairs, or the bevel node to refine the edges. These are just a few examples of what you can build by applying the same logic we covered, plus a few extra nodes and maybe a couple more cups of coffee. It would be overwhelming to cover all of this in a single tutorial, but I hope you get the point of what can be done using geometry nodes. Here, for example, I automatically generated all the UV maps of the stairs. So, We covered the simple stairs asset, but I challenge you to continue it and create the handrail. Let me know in the comments if you have any questions or need any help. I love talking about geometry nodes, and it took some time to put this tutorial together, so I really hope someone out there learned something new. Thanks so much for watching.